Hi everyone, welcome to the Notes on 3.2, Day 2, Part 2. I apologize, this is not the way that I would like to be doing this, but I am trying my best. Okay, I just wrote some things to start so that hopefully the the document camera wouldn't get as blurry for you. So I'm still looking at that parent function of log base 2, which we found on the other side of these notes. So I wrote down my x parent function value, my y parent function value. So let's look at this in terms of transformations. Is anything happening to the argument? Is anything happening to the input? No, so we can write xp and x are equivalent to each other. Okay, so I'm going to rewrite my 1/4, my 1/2, my 1, my 2, and my 4. Okay, and now what is happening to my y values are going to be -2 times my y parent values. So -2 times -2 is 4, -2 times 1 is -2, 0 times -2 is 0, -2 times 1 is -2, and -2 times 2 is -4. And again, I'm sorry, I missed this negative, so this one should be positive. I apologize about that. Okay, so now we're just going to graph these. So my x values are going from 1/4 up to 4. So I can just go 1, 2, 3, 4. My y values are going from -4 to 4. Okay, so I am graphing 1/4 all the way up at 4. And then I'm graphing 1/2 and up at 2. And 1, 0. And 2, -2. And 4, -4. And I'm drawing in my smooth logarithmic curve. Okay, so this makes sense to me. Okay, I didn't have a vertical shift, and I didn't have I didn't have a horizontal shift. I didn't have a vertical shift. What I did have was a reflection over the x-axis, and so this does look like a reflection from the graph I found on the previous side. And I have a stretch of 2, a vertical stretch of 2, which it looks like to me as well. So our domain, again, we are not using any of our negative x values or our 0, so our domain is from 0 to infinity. My range is all real numbers, so I'm doing -infinity to infinity. I don't mind if you use the double-backed R. I'm just trying to use this notation because I think if I need you to enter something online in a quiz, you're going to have to enter something like this. My intercept this time, I have one at 1, 0, and I can see that my asymptote is at x equals 0. So I'm going to draw that in as well. So if you are having questions about how I'm coming up with these tables, right, please go back and look at your transformation notes because we're using the same method, okay? The only thing that's new is our parent function is now this logarithmic base 2 function, okay? I will say if you are starting to do your homework and you have a base 3 or a base 4, you actually, just like we did on the other side, you probably will need to find the exponential growth using -2, -1, 0, 1, and 2 for x, and then switch the table to find your logarithmic parent function. Okay, so you want to use that same method. Okay, next, we are going to talk about 2 special types of logarithms. Okay, this first is called common logarithms. Okay, so logarithms with base 10 can be written as log x. So anytime you don't see a base in here, it's implicit, it's understood to be 10. Okay, and that's something you need to memorize. Okay, so again, all this means is it's shorthand. Okay, it comes up so frequently. Mathematicians and scientists use base 10 so frequently, right? It's our counting system is all base 10, that they decided a shorthand would be log x. Okay, and logarithms with base e are called the natural log. So instead of writing log base e of x, they always write it ln, which we say the natural log of x. A lot of times when people are first seeing this, the natural log, I think they're kind of confused because they think, why wouldn't it be NL? It was actually LN because the first mathematician to use it was French. And so some of you that take French, you might know how to say the natural logarithm, but I think the logarithm came first and the adjective came after, and so that's why we say the ln of x. You will hear a lot of people abbreviate it as the ln of x. I will probably slip up. Technically, I would like to hear you saying the natural log of x, okay? It's a little more sophisticated and it's a little more exact. So we have the same properties for the natural logarithms and for the base 10 logarithms. Okay, here's the natural log of 1. So that means our base, this is the same as log base e of 1. And hopefully you remember for anything from yesterday, for any base, if the argument is 1, our answer is 0. Okay, and the natural log of e, again, this is the same as log base e to e. What exponent do we need to raise e to get e? 1. Okay, so the natural log of e is 1. Okay, same here. The natural log of e raised to the x. My base here is e. What do I need to raise e to get e to the x? X. Excuse me. And here, my two bases are the same. So this is our property that we used yesterday. E to the natural log of x will just be x. Okay, these are probably properties that are worth memorizing. They come up a lot, especially if you're thinking about taking calculus next year. Okay, and it's something you want to recognize pretty regularly. And again, you do want to realize that when you're dealing with the natural log, your base is e. When you're dealing with just the common log without a base, or without an explicit base, the base is understood to be 10. Okay, these are things that you want to be able to evaluate without a calculator. Okay, so log of 1,000, my base is 10. So 10 to what power gives me 1,000? To the third. Okay, for B, 10 to what power gives me 10 to the eighth? 8. Here, log 10 raised to the log of 33. What's my base up here? 10. Any base raised to the log of that base is equal to the argument. For part D, e, our base here is e. E raised to the what gives us e to the sixth. 6. Some of you, just to make sure you can see this, I know some people aren't super comfortable. This is ln 1 over e to the 7th can be rewritten as e to the negative 7. So e raised to what base gives us e to the negative 7th? Sorry, e to what exponent gives us e to the negative 7? Negative 7. Okay, and here, e raised to the ln of 300. My base here is e. My base here is e. So this will just be 300 using those same properties from yesterday. Okay, example 3. Same thing here. My base is e. E to the what gives me e to the raised to the 13x. It will just be 13x. 10 raised to the log of the cube root of x. Base here is 10. Base here is understood to be 10. These are the properties from yesterday, so this should be cube root of x. E raised to the natural log of 7x squared. Here, our base is e, our base is e, so using the inverse properties of logarithms, this will be equal to 7x squared. Okay, our last example involves word problems.